Hello, this is the autonomous mapping robot for RBE 3002 class at Worcester Polytechnic Institute. My name is John Pearsall.
I'm Andrew Brown.
And I'm Jonathan Estabrook.
This is a demonstration of our robot navigating its way through 5 different waypoints to the end of its environment and then navigating its way back to the start point where it just was. Each waypoint is put in successively, so it will go to waypoint 1, which you can see in front of it, then to 2, then to 3, then to 4, and then to 5. As you can see, our robot just hit waypoint 1. It is now scanning and looking for the second waypoint. If you notice, our scanning is done in 3 different ways. Actually, 2 different ways. The scanning it's doing now is scanning its right, its center, and then its left. When we go from one waypoint to the next waypoint, it scans in an arc to try and get any sort of obstacle in its path. Our robot just hit waypoint 2. Now it is going to do the arc scanning, looking for waypoint 3. Waypoint 3 is directly in front of it, and now it's on top of waypoint 3. And waypoint 4, as you can see, is the closest one to the camera. Now it's going to scan for waypoint 4. The reason we do the 3 segmented scan is because the IR and sonar give extended readings when looking at walls on angles or into corners. So we instead just look 90 degrees from the robot and assume that it's going to hit a wall at a right angle. Now the robot is navigating towards waypoint 5, which you can see in the corner of the screen. I'm sorry for the shaky video camera, but I'm holding up my laptop and recording the video through its webcam. Now the robot is at waypoint 5. It needs to navigate its way all the way back to the start point. It is scanning a wall here because it wants to navigate through the outside of the course back to the original waypoint. From waypoint 5 to the starting waypoint, the robot only has its navigation software to bring it back to the original waypoint and the scanning data it's doing now and previously from waypoint to waypoint. It does not want to go back to waypoint 4, then 3, then 2, then 1, so it doesn't necessarily have to hit each waypoint on its way back. We put an obstacle, a wall, just around this corner for our robot to navigate past, and right here it actually scans the wall and plans a path around the obstacle we just placed there. Originally our robot would move 1 step at a time, but now it moves 3 steps at a time. And here's our robot navigating past the wall, the obstacle we placed on the course after it had already been there. We removed the wall for viewing reasons. It's easier to view the robot from here. It wants to go right into that cul-de-sac, but the sensors saw a phantom obstacle there and causes the robot to rescan all its previous areas because it's trying to go through a wall it hasn't yet scanned to the start point and avoid that obstacle. And by the way, this video is sped up 5 times. Our robot is trying to navigate through that area, but because of the phantom obstacle, it doesn't think it will fit. And now it is stuck in limbo trying to scan all of the obstacles and try and find an opening in the phantom obstacle there. There was a problem with our sensor algorithm that it would see phantom obstacles, and what we would need to modify later on is that an area scanned by the sensor, if it didn't see any obstacle, it could mark that area as clear on the map and update the map.
We would like to thank our teachers, Professor Chernova and Professor Padir. Our TAs, Justin, John, and Ray, because they're incredibly helpful while doing this experiment, and our lab aficionado, Joe St. Germain, because, well, when the robots were broken, he would spend countless hours trying to fix them. We would like to thank you for watching this, and I hope you have a great day.